So hopefully with your investigation, you got to find these laws right here, that if I have two logs that are being added together, right here, I can multiply their a and b. If I have two logs that are being subtracted from each other, I can divide their a over b. And I can always rearrange a log that's being multiplied by a number into the exponent of the log. So what we see is we did our problems based off of base 10, but it's still true to follow those rules when our base is any number other than other than 1. So if you notice, it's still the same rules. I can multiply when I have addition, I can divide when I have subtraction, and I can rewrite when I am being multiplied by a number. So let's actually do some of these practice problems together. And what we see here is I have two things being, two things being added together, which means we are allowed to multiply our numbers. So that gives us the log of 5 times 3, which is equal to the log of 15. In number 2, I see that I have base 3 and I also have a base 3 here. So I'm allowed to do log 3. And since it's subtraction, I can divide 24 divided by 8. And if we simplify that, we get log 3 of 3. And for us, we know that this is the same as 3 to the x is equal to 3, which means our x must equal 1, right? Okay, so we take a look at this next one. We have log 5 minus 1. Well, we need to get them to be in the same same base. So what we do know is we want to write something where it says log 2. Well, this only happens, as we can see from above, if this number is 2. Right? Isn't log 2 2? When these cancel, we get a 1. Now that I'm in base 2s, I can use the rules. And this gives us log base 2 of 5 over 2. You kind of just finish it right there. So if you notice you do not have the same base, you have to use some tricks so that we can get the same base to follow the rules. Let's go ahead and try these right here. Well, I can see that I am in the same base, but before I can use the rules, I need to make sure I move these numbers. So I'm going to change this to log of 7 squared minus the log of 2 cubed. That's going to give us the log of 7 squared over 2 cubed, and if we simplify, we get the log of 49 over 8. Okay, let's try number 5 right here. Again, we see we want to rewrite this to log of 3 squared. We also see that this right here does not match what we currently have. So the only way we can see this is if we initially had 3 log. Technically we're in base 10, so we get log 10. Right? So we do now have matching logs with base 10s. Technically log 10 is equal to 1. 1 times 3 will give us this original part right here. If we now use our rules, we are allowed to multiply and we get log of 3 squared. Oh, sorry, I forgot to rewrite that portion again. I didn't finish the rewrite. What we end up seeing is we get log, and that's already multiplied, of 9, plus log of 10 cubed. That will give us the log. 10 cubed is 1,000 times 9 is log of 9,000. So we're going to try this problem right here. We see we have log 8 over log 4. And part of you might say, let's use a subtraction rule, but what we notice is there's a log on the top and a log on the bottom. So just like usual, we want to get the same base. That means we are going to have a log base 2 to the 2 to the third over log 2 squared. We go ahead and move our exponents out front, and once that's done, we notice our log 2's cancel, and our final answer is 3 over 2. Alright, so let's go ahead and try a couple more problems. If you take a look here, it says, show that the log of 1 over 9 is equal to negative 2 log 3. So in order to do that, I know I want to rewrite our left-hand side. I'm going to rewrite that to log of 9 to the, actually let's do it this way. We know 9 is the same thing as 3 squared. So we'll do log of 1 over 3 squared equals negative 2 log of 3. We want to move our power up top, so that gives us log of 3 to the negative 2 equals negative 2 log 3. And using our log rules, I know I'm allowed to move the power out front, so that gives us negative 2 log 3, which is exactly what we wanted to show right there. Let's go ahead and try this right here. So what we have is log of 500 is equal to 3 minus log 2. So what we're going to do is, since we know we have a subtraction sign, we need to create a fraction. And one way we could do this is if we say 500 is actually the same thing as 100 over 2, this will help us out. Now you may ask, well, why do I want to use a 2? Well, as you can see, we know we need a fraction because of the minus sign. We also know we need a log 2 because of the second portion of this problem. So that allows me to split this up to get log of 100 minus log of 2. So as you can see, we're really close to getting our 3 minus log 2. I know 100 is the same as 10 squared minus log 2. I'm sorry, 1,000. I apologize for that. It's 1,000. That gives us a 3 right here. So we get log 2. We use our rule and we get 3 log 10 minus log 2 is equal to 3 minus log 2. And we know this is true since log 10 is equal to 1. And you see we get 3 minus log 2 equal to 3 minus log 2. So now let's take a look. How do we go from problems that don't have logs in them and rewriting them so that we can have logs? So right here, as you can see, I have y equals a squared b. What I need to do is log both sides. So I log y. That gives me log of a squared b. I see that we have multiplication. So since we have multiplication, I know I can rewrite that as log y is equal to log a squared plus log of b. And finally, the last rule we're going to have to use is the exponent rule. So I get log y is equal to 2 log a plus log b. Sorry for the handwriting. Do the same thing here, and we get log of y is equal to log of a over b cubed. That signals subtraction, so we get log of y is equal to log of a minus log of b cubed. And again, I use the exponent rule, and if I move this back up here, I end up with log of y is equal to log of a. minus 3 log of b. Let's go ahead and take a look at the next problem down here. I'm going to do the same thing, even though I don't have y's in here or a's and b's. I can still log p. This gives me log of 20 over radical n. That allows me to do log p is equal to log of 20 minus log. I'm going to rewrite that as n to the 1/2. So once I do this, I end up with log of p is equal to log of 20 minus 1/2 log of n. Okay, so let's do one more problem. Here it says write without logarithms. So we're going to do the opposite of what we did earlier. We're actually going to use our logarithm rules. What we know is I'm allowed to rewrite some of these. I get log of a is equal to log of b plus log of c squared. Right, so I'm going to move that back to the exponent. I have addition, so that means I'm allowed to multiply these to get log of bc squared. And I know to get rid of log, I have to do a base 10. This cancels, and I end up with a is equal to bc squared. And let's try this for our last problem right here. And we see the same thing. This gives me a log 2m equals a 3 log 2 with an a minus 2. What I want to do is first I want to rewrite this so that I can move that third power. So I know I move this to that a, get log 2m is equal to log 2a cubed. Now I know I need things to be in log 2, so I'm going to rewrite this as log 2, 2. And that means if this is equal to 1, that 2 must stay out here. So technically, if I rewrite this again, I get log of 2a cubed minus log of 2 squared. Since I have subtraction, I have log 2 of m is equal to log 2 of a cubed over 2 squared. Right? Now, since I am at base 2, I do a 2 to that. This cancels, and I end up with m is equal to a cubed over 4. So there's an overview on logarithms. I'd like you to practice some of these problems, and when we return from Thanksgiving, you'll be able to take a look at these. Okay, thank you.